In this lab, we are going to practice another implementation of stacks. In the previous lab, we studied a finite stack. Here, finite means the stack uses array as a storage. So when you create an array, the maximum capacity is set there. So you cannot exceed the maximum capacity set. The problem with using array is to guess the proper size of that in advance. If you make the array size too big, you are wasting memory. If the array size is not big enough, then in the middle of the program execution, the program gets into trouble. So to avoid the problem of predicting the array size, storage size in advance, another implementation is called infinite stack. Infinite stack is based on creating the storage on demand. So as you do push, then create the storage for the data and store that. Here the idea is that we are going to have some minimal storage where we want to store data. So let's call it as node. We are going to create a class for node later. So in the node, the structure is that you store data and then you store another info that is a address of another node. So here the first one you store data for stacks. As you do push, the data is stored in this member. But another one is a address of the another node so that you can make link together those multiple nodes. So the infinite stack, the idea works as follows. So at the very beginning, you will have a pointer to a node. So at the very beginning, when the stack is created, it points to nothing. So in graphical representation, nothing is being pointed. We use electrical circuit notation called earth. So this is just a graphical symbol, but in actual programming, null pointer, null PTR is the value which is a zero address equivalent ones. So at the very beginning we have a pointer which is null pointer, which is zero, nothing is being pointed up. But when you do first push, suppose 10, then what you do is you create a node structure where data 10 is stored, and then the stack pointer is now pointing to the node. So address of this node is stored in a pointer. And so this is representing stack. And then pointer within the node structure, there's nothing after that. So we construct this kind of picture. So if we do push again, like value 20, so we create the node structure where data 20 is stored. Now this node is the last entered one, so the stack pointer should point. Now update that. Stack pointer is pointing the new one just entered into the stack. And then this new one is pointing to the second to the last one entered, the one existing one. And this one has nothing after that. So we keep creating this kind of a linked structure where the node structure is used to store the stack information.